Hi friends, and welcome to the SQL Bits 2020 session, Designing Azure Data Disaster Recovery Strategies. While we all wish we could be in beautiful London at this point in time, unfortunately we're unable to do so, so we are pre-recording these sessions. So with that, let's go ahead and jump in and get started. I'm John Morehouse. I'm a consultant with Denny Cherry Associates. My contact information is on the slide before you. Feel free to connect with me on LinkedIn. I am on Twitter as SQLRUs. I do blog at SQLRUs.com. I will say that I blog a lot about the internals of SQL Server, branching out more into Azure and the cloud, as well as automation. I like PowerShell and making things easier, so I do blog about automation at times. I am a frequent speaker. I speak quite a bit. I'm an avid blogger and tweeter. I am a Microsoft MVP in a data platform. I am a VMware V expert, and I help organize SQL Saturday conferences. Briefly about Denny Cherry Associates, we're a small boutique of IT professionals that specialize in SQL Server. So if your organization is looking for SQL Server help, would be happy to talk to you and see if we can help you improve performance and or move migrations around to Azure as well. So in our journey today, we're going to talk about a number of things, and we have quite a bit of information to kind of go through, and hopefully we can make it to the end. But first, we're going to talk about objectives and what kind of objectives should we have when we talk about disaster recovery, specifically in Azure. We're going to talk about some terminology. If you're already well familiar with the Azure cloud, some of this might be a review, but if you're just thinking about going to the cloud, we do need to think about disaster recovery, so we're going to touch on some of these terminologies so that when you think about these strategies and decide on a path to go down, you know what everything means and you know how everything is going to operate. We're going to talk about what you get out of the box with the three major SQL products in Azure and what those metrics mean and why they're kind of important. Then we're going to talk about some backups, the bread and butter of disaster recovery for database administrators everywhere. We're going to talk about how backups work in Azure. And then we're going to talk about availability groups and what you can do with them in Azure, as well as the offerings for the platform as a service, Failover Groups, and Geo-Replication. And then we should hopefully have time for some demos, and then we can look and see how some of these things actually play together. So first and foremost, we need to talk about the BACKHOE phenomenon. So we have conversations with organizations today in 2020 that think that when we go to the Azure cloud, or any cloud for that matter, that disaster recovery is no longer a worry and we don't have to think about it. Unfortunately, that is not the case. Even when going to Azure, and again, any cloud provider, disaster recovery is just as important as it is when you work with on-premise solutions. We have things called BACKHOE phenomenon, or others might know it as a rabid backhoe, where a construction worker, unbeknownst to him, cuts the wrong cable accidentally and a whole data center goes down, or something else drastically happened. I've actually seen that on occasion where this was an on-premise environment, but we were constructing a new building and the backhoe operator cut the wrong line and took down our entire facility. So this does happen with Azure cloud resources on occasion. It is not intended, but we have to plan for it. We have to be able to plan for these rabid backhoes. When they do occur, we have something in place to ensure that our data is secure from that type of disaster. We also want to make sure that we take into account weather events. For those of us that live on the East Coast of the United States, we deal with hurricanes. Now, thankfully, I'm a little bit more inland, so they don't usually affect me that much. But my colleagues and coworkers and friends that live closer on the eastern seaboard, they get to deal with that. And there are data centers on the eastern seaboard of the United States, and so we want to plan for that. When we talk about disaster recovery with Azure or any cloud provider, we do still want to understand what our objectives are. And these objectives are the exact same thing that we would have when we do on-premise solution design. So we want to talk about what's our RPO, which is the recovery point objective. And this really means how much data can we stand to lose. Now, on-premise, that might be a different number than what it is in the cloud, but that number still needs to be defined and well documented so we know what numbers we have to hit. In my opinion, as a database administrator, I usually like to have an RPO of 15 minutes, but that really depends on what your tolerance is for your business. I've seen organizations that have a smaller RPO amount, and I've seen businesses that have a higher RPO amount. We also want to talk about recovery time objective, or RTO. How long of a duration of an outage can we withstand? Is it 15 minutes? Is it an hour? Is it 20 hours? Is it 2 days? Whatever that number might be. What that number might be will help dictate what kind of solution you put into place in the cloud to ensure that you can meet your RTO objective. The other thing that I'd like to point out is that these objectives aren't fluid. They shouldn't be flexible in one situation and flexible in another situation and have a moving target. It's really like the bullseye on the dartboard. We want to always try to aim for those objectives and not move that goalpost. So make sure that they are not moving around on you. Otherwise, it becomes difficult to find a given strategy that'll meet those objectives consistently. And consistency in a disaster recovery scenario or strategy is really important. So we want to make sure that that solution always meets the needs. So let's talk about terminology real quick. We kind of talked about the BACKHOE phenomenon. We talked about some objectives and understanding that. So let's talk about terminologies. So first and foremost, we have to talk about geographies, regions, and zones. As I mentioned previously, if you're well versed in the cloud and or Azure cloud, you're probably already familiar with these terms. But again, if you're moving to Azure from a standpoint right now, understanding what these terms mean not only helps with your production environment, but also helps with your disaster recovery scenarios. We're going to talk about PAW and what that means. We're going to talk about high availability and how high availability doesn't really mean disaster recovery. And then we're going to talk about storage, the LRS, ZRS. These acronyms really relate to storage and how the storage is being replicated around multiple regions or geographies. And many of the products in Azure SQL is based off back-end storage. So understanding these terminologies is important. So let's jump into geographies. As we know, the world is divided into different geographies. These geographies are either defined by physical boundaries and or geopolitical boundaries or country borders. And so each geography would have individual regions within it. And within that geography, those regions are defined by a bandwidth or a latency envelope, which are usually hundreds of miles apart. So region 1 is 100 miles or more away from region 2. Understanding where the regions are within a given geography is important so that we can ensure that our data is further away from our production environment. I'm going to use the hurricane example again. If we have a hurricane come along the eastern seaboard and wipe out our production data center, Azure data center somewhere on the eastern seaboard, we also don't want our disaster recovery solution to also reside in that same region. We want it to be further away. The regions also provide us individual electrical, power, cooling, and so we can isolate our disaster recovery data elsewhere, and so we have no longer single faults of failure. Now here we can see that there are multiple regions spread out across the globe, and so we can actually put our disaster recovery solution to put data wherever we want. Now we're going to incur charges. If we move data from one region to another, or we span a great distance, you're going to incur charges by moving that data around. However, if your organization dictates that your disaster recovery solution says that you want to put data in Central Europe, whereas your production data is in the United States, you could facilitate that with the Azure resources. This is kind of helpful because then we have greater capability of our disaster planning. I remember back in the day where disaster recovery was Iron Mountain. We'd write everything to tape, and then a guy in a white hat would show up with a case and actually collect the physical tapes and take them off and store them in a temperature-controlled, security-controlled vault somewhere. In order to get that data back, the guy in the white hat had to come back with the tape, and we would load that tape back into our data center. So regions are helpful to ensure that our data is spread out across multiple areas. Within certain regions that support them, there are concepts called availability zones. An availability zone allows us to have independent and isolated power, networking, cooling, all that within that given region. Now, when we talk about regions, we don't, as Azure customers, we can't see which specific data center our data might reside in. We actually just talk about the region at the region level, and then the service actually dictates where that data might be sitting. But within that region, we can actually provide disaster recovery even further by using availability zones to ensure that it would survive that independent data centers going down. So if my data was in data center alpha, and I could actually use availability zones to ensure high availability and that my disaster recovery was available within that same region by specifying another availability zone. If the alpha data center went down, then my data would still be functional in a secondary data center within that region. So we can actually get granular level from a disaster recovery solution. Just remember that that is still within that given region. And I'm a very large proponent of moving that data out of your primary region, just in case you get natural events like a hurricane. A hurricane or a tornado could come through and wipe out the entire region. And that would be disastrous because you haven't planned for it and moved your data outside of that region. One of the other benefits about Azure are things called sibling regions or paired regions. Certain regions have a sibling region, which means that data is automatically replicated from the primary region to a secondary region. This region is not controllable, meaning that you can't pick which other sibling region your data is going to. We don't have control over that, but knowing that we put data in a certain region, then that data is automatically replicated to a secondary region, which is 100 miles apart. That is beneficial to ensuring that your data can survive disasters. The sibling regions obviously provide physical isolation because they are far apart, as well as isolated cooling, network, and all that stuff. The platform itself provides the replication between sibling regions. We as consumers don't actually have to set anything up to facilitate this replication from one region to another. The service itself does that. Sibling regions also provide a recovery order, meaning that if it's going to do maintenance and or has to recover certain regions, it's going to touch one individual region first before it touches the sibling region. This ensures that one region is always not being manipulated by the service. Same thing with sequential updates. The sibling regions will only be updated sequentially, so that way, again, one region was only being manipulated at a time to ensure that we provide service to the consumer at all times. In the United States, we have a couple sibling regions available to us. This is the existing list. And again, remember that we don't have any control as to where that sibling region is, but we can see that the East US region has a sibling region of West US region. So that means that data, if I put it in the East US region, then my data is automatically replicated to the West US all the way across the continental United States, well on the other side. So hopefully a hurricane is not going to affect the East Coast and the West Coast at the same time, but that data I know for sure that data is going to be replicated across to the West US. So speaking about replicating that data that far apart, we have to talk about physics always wins, or PAW. Okay. You can't beat the speed of light. You can't beat the physics of the nature of the cloud. And so when we replicate data from one region to another, from East US to West US, we have to think about the latency of moving that data across that distance. It is a physical distance that it has to travel. And so we have to think about, in a disaster recovery scenario, where is that data going to sit and how is that going to affect our consumers in the event of a disaster and we have to access that data, whether it's a blob storage or we fail a database over, whatever. If our primary consumers are based out of, say, the East Coast of the United States, and we have a disaster and we have to fail over to the West US, what is that latency going to do to our application and the user experience of our consumers? Maybe that latency is too great for our application and we have to adjust. Maybe instead of the West US, we bring the data a little bit closer to the Central US, where it's still physically isolated across multiple hundreds of miles, but it is closer to our consumers in the event of a disaster. So we have to think about where are the resources going to sit and how are we going to get there and ensure that the latency is going to be acceptable for our disaster recovery solution. This is one thing to note, that if you can design a solution in Azure to test this, and there are products available that will help you do this, testing this disaster recovery solution in Azure is just as important as testing it on premise. You should be testing your DR solutions in any environment to ensure that it does what you need it to do. Now, the one thing you can do, if you've got a big checkbook, you can sometimes help get physics on your side. You can purchase express routes, which is basically a direct highway to Azure, to help you beat the physics, but you can't always win, right? Physics is always going to beat you eventually, but you can do things that will help you get faster and better latency with a bigger checkbook. Don't know if that's always, the bigger pipe you get to your DR, usually the less latency you're going to have, and so you have a better outcome and experience for your end users. So one of the other things that we talk about when we talk about disaster recovery in Azure or any cloud environment is that HA, or high availability, isn't the same as disaster recovery. High availability is usually within the same data center. If you want to think about like an availability group, you can use availability groups for disaster recovery, but most organizations uses high availability groups for high availability. You've got 2 nodes or more in the same data center. They replicate data between the 2 nodes, and that provides, in case one node goes down, the other secondary node picks up the load and provides service to the applications and the consumers. It's not the same as high availability. You can use, as I mentioned with availability groups, you can use high availability as a DR methodology. Just understand what the differences are and ensure that that solution is going to meet your needs in a disaster recovery. If you have 2 nodes within the same data center and the whole data center goes down, then that's not going to be a disaster recovery solution. That's not going to fit your needs. But you could use the tool, which would be availability groups in this example, to replicate your data elsewhere outside of the region, if you're using SQL Server on an Azure virtual machine, to ensure that that is a disaster recovery solution. That you could do. Usually a DR solution, your DR is going to be greater than 100 miles. I have organizations, or I know of organizations, that their DR is actually 10 blocks down the street. That is not, in my opinion, a DR solution, because what if an event comes along, say a tornado, and wipes out all of downtown, and your primary data center and your disaster recovery data center is all within the same 10 block radius? That's not going to be a good solution, in my opinion. If you have that today, I'd strongly urge you to look at your DR solution and find ways to get it out of the immediate vicinity of your primary data center. Even in Azure, if you look at your Azure footprint and all your data is co-located within the same region, the same availability zone, whatever it might be, try to get it out of there in some fashion. With HA and DR, we obviously have synchronous and asynchronous commits within SQL Server. And storage replication within Azure works in the same manner. We have to think about how we are transmitting data with disaster recovery across a vast distance. You're not going to want to use synchronous commits to move data from point A to point B, especially if it's over a great distance, because that's going to introduce latency within your application. So we also have to think about this. Just keep in mind that if you have overall bad performance within your application, moving or implementing an HA or a DR solution might not fix your performance issues, and neither of these is about fixing performance issues. This is about fixing the viability of your data in the event of a disaster to ensure that your business and your consumers can continue to function and operate and make money in the event of a disaster. So now that we've talked about HA not being the same as DR, let's talk about some storage terminology. Understanding the back-end storage that is implemented within the Azure environment is pretty important. And we have a couple different options when it comes to storage and the way that data is replicated between the two. The lowest granular, not really replicated data is actually locally redundant storage. Now, this means that the storage is locally redundant within that given physical facility, and you get 3 basic copies of that data within that facility, which means is that if that one server rack goes down, your data is actually replicated to 2 other server racks within that physical location. So while you might be redundant from a individual server rack failure, you might not be redundant. So you're not going to be redundant from that physical location from going down. So you do get a high number of high availability nines. So you get 11 nines with this, which means that the locally redundant storage is going to be up and serviceable 99.99999% of the time, but it's only locally redundant within that one physical location. Now, if we come back out a step and talk about zone redundant storage, so remember that LRS, or locally redundant storage, is going to be within a physical location within a region. Now, zone redundant storage is going to be redundant within multiple zones within that region. So we talked about availability zones a few slides back. This is where the storage is going to be then replicated between the zones within that given region. So we've kind of stepped back away from that physical location. Now we're kind of at a higher level into the zone itself, and with a little bit higher within the region. Now we can take another step up higher into the region and talk about geo-redundant storage. So geo-redundant storage is going to give us the ability to replicate our data across multiple regions. And so this is how we facilitate our objectives by ensuring that our data is replicated outside of a given region. We can do that with geo-redundant storage. Now we can also do what's called geo-zone redundant storage, where geo-zone redundant storage, the acronyms get really complicated sometimes. This storage is replicated within the zone itself, the availability zones within the region, as well as replicated outside of the region. So we kind of get double replication with the geo-zone redundant storage. Now, one thing to keep in mind is that this storage, all four of these right now, are not accessible by consumers unless Microsoft initiates a failover. So if we have locally redundant storage, let's say I store data within the physical location and locally redundant storage, I know that it is replicated 3 separate times within that location. I have a primary and 2 secondaries. I can't see those secondaries. The only thing I can access is the primary. The only time I'd be able to see that secondary copy is if Microsoft initiated a failover to that secondary copy for some reason. I, as a consumer, cannot initiate that storage or that failover. Now, we can make some of the geo-redundant storage readable. So I can configure geo-redundant storage to say, hey, on the secondary, I want to be able to read that data. So I can configure that when I set up the storage to say that storage on the secondary side is going to be readable. This could be useful if you have an application that you want to offload some reporting, CPU, whatever, to that secondary. Then you could read that data once it gets replicated over and it lands in that secondary region. You could then read it with your application, or your consumers could, depending on what their needs are. So you can configure that readable secondary, but you have to configure it when you set up the storage account. So let's talk about what we get out of the box just for a second. Now, out of the box, this is going to be more of high availability, but high availability, while it's not the same thing as a disaster recovery solution, high availability can dictate what your disaster recovery objectives and what that overall solution is going to be. Now, out of the box, we get 4 nines with Azure SQL Database, which means that we experience 52.60 minutes per year of downtime, which over the span of 365 days, that's not a lot in my opinion. Same thing with Azure SQL Managed Instances. If you have either one of those 2 products, you get 4 nines right out of the box from the get-go. With Azure Virtual Machines, you get a little bit less. You actually have 3 nines, and so you experience roughly 9 hours of downtime per year. Take these numbers into consideration when you start to look at your Azure disaster recovery solution, in that if you have an application that DR might not be that big of a thing, and maybe you don't need DR because you can reproduce the data, maybe just having the high availability and the level of service that the provider or Azure provides for you might be sufficient. That makes me a little uncomfortable as a DBA. I want to make sure that my data can survive a disaster. But I know that some organizations or some applications, you can reproduce the data, you can recreate the data. Understanding what you get out of the box in terms of service SLAs can be important in designing and deciding what disaster recovery solution will fit your needs. So we've kind of talked at a high level about the terminology, understanding what the physics are, the breakdown of the regions and geographies. Let's talk about some solutions in terms of thinking about disaster recovery solutions. So I've kind of put together a brief matrix of options, what the strategy is, and then what service tier that it would apply to. For example, controlled backups. As a database administrator, I want to have the ability to control my backups, know where they are backing up to, be able to touch those backup files, as well as bring them down and or utilize them to restore on demand. Now, I can't do that with platforms as a service. Azure SQL Database and Azure SQL Managed Instance, those backups are controlled automatically by the service. Now, with Azure SQL Managed Instance, I can take a copy-only backup, but I can't control the full backup or the differentials or the transaction log backups. The service controls all that for me. To me, that's a pro and con. Now, if I'm using Azure, or I have a SQL Server on an Azure virtual machine, I do have that ability to control those backups and know where those backups are going, and as well as be able to manipulate those backups. So I can use that. There are products called Azure Site Recovery or Azure Backups. The service offers this as an add-on, and so you can actually configure the Azure Site Recovery to replicate your VM itself to another location, as well as I can configure Azure Backup to manually control the backups of the SQL instance within that virtual machine. In a sense, the Azure Backup allows me to configure that within the portal and not have to drive down into the virtual machine to actually configure it at the SQL level. It's actually controlled at the VM level, and the service will do that for you. But I can't use those two products with platform as a service in either product. So keep in mind that Azure SQL Database, Azure SQL Managed are both platform as a service. SQL Server on an Azure virtual machine is infrastructure as a service. So those are the three tiers that we play with. Automatic failover groups. Automatic failover groups is basically utilizes availability groups under the hood. I can't configure that with infrastructure as a service. So SQL Server on an Azure virtual machine. I can configure actual full-born availability groups on a SQL Server on Azure virtual machine, but I can configure automatic failover groups with platforms as a service. Same thing with active Geo-Replication. Now, there are differences between failover groups and active Geo-Replication, and we'll talk about that in a future slide. But these are two options that I can use to configure disaster recovery solutions for the products that fall in the platform as a service category. As I mentioned earlier, I can use availability groups with infrastructure as a service, but I don't have access to the underlying infrastructure with platform as a service. So availability groups only allows me to replicate data with SQL Server on an Azure virtual machine. I can't use it with SQL Database or SQL Managed Instance. So those are some options that you have available to you, and we'll talk about each of them here in a minute. Let's also talk about storage tiers. So when we talk about storage tiers, and blob storage in Azure is a great place to store long-term data. But there are a couple different tiers. The first tiers we're going to talk about is the hot tier. This tier facilitates frequently accessed data, but it comes with a higher cost. And so this is data that we want to be able to land in Azure Blob Storage as well as read from that storage without any delays. And so this is going to be a higher cost, as I mentioned, but we can actually go down a level to the cool storage. And this means that we're going to land data and we're going to keep that data there for at least 30 days. We have a lower cost amount for cool storage, and we have the same speeds as hot storage, but we have to keep that data there for at least 30 days. And then we can actually go even a step further and say we want an archive tier. This is data that we're going to land in blob storage, but we're not going to touch it, and it's going to sit there for years and years or however long. I actually have a client that I use the cool storage tier to push SQL. They have an on-premises SQL server, and I actually push their backups up to cool storage in Azure to meet the needs of their disaster recovery plan. They say that they have to keep at least 30 days physically on site as well as 30 days in the cloud, just in case that local on-premises data center goes away in some fashion. I still have access to all the backups of their SQL servers in Azure storage for at least 30 days. The archive storage tier, we have to keep it there for 180 days. It is the cheapest cost. So if you have data that you want to retain in terms of backups, and you're not going to touch it for at least 180 days, go look at the archive tier. It's super cheap and a super great way to ensure that your data is retained. Now, all of these tiers can be configured with the redundancy that we talked about earlier. So I can have a locally redundant hot tier, or I can have a geo-redundant cool tier. you get to specify which tier is redundant in which manner. So keep in mind that with a cool and archive, I mentioned that we have to keep it there for a certain number of days. If you extract that data before that mark, before let's say the 30 days, then you actually get a withdrawal penalty. So you get hit with the retention period minus however many days you spent in storage. You still have to pay for that difference. So you do get hit with a early withdrawal penalty if you remove it from that storage tier before that marker or that deadline. So let's talk about Azure Site Recovery and Azure Backup. So let's talk about first Azure Site Recovery. The image on the right is what the physical topology looks like in terms of Azure Site Recovery. And Azure Site Recovery is basically a block replication. So if you think about it, on your local premises, you might have a SAN, and in that SAN you might have something like Zerto, or the SAN itself might have some sort of block level replication where it replicates the physical block of the disks up to another data center somewhere else, and that is how you do disaster recovery. Azure Site Recovery works in the same manner. So if you had a virtual machine in Azure, it would facilitate block level replication from one data center or one region to another. One of the beauties about Azure Site Recovery is that it gives you the ability to test these failovers. So you can actually test the disaster recovery solution through the Azure Site Recovery. Another nice feature about Azure Site Recovery is that it is two-way. So in the event you had to fail over, you would automatically pick up the primary and immediately start to replicate back to the new secondary. So that's a nice feature that is available to you. I don't recommend it per se for a SQL Server on Azure Virtual Machine. However, if you have web servers or some other virtual machine that is not, say, transactionally consistent database platform, I think this is a great solution. And it's relatively inexpensive, but definitely double check your platform and your footprint to see what it might cost. But that is Azure Site Recovery. Azure Backup, as I mentioned before, there's a service that you can configure on your virtual machine in Azure that will take care of your backups of the SQL databases on the instance that is on the virtual machine. Many of us might be familiar with configuring and setting up Ola Holograms scripts to manage those backups. You can certainly still use that on a SQL Server on Azure Virtual Machine if you want to do that. This product will actually just configure it within the portal. When you can go into the virtual machine and configure it, it will do your backups according to whatever policies you set up. So you can configure daily fulls or weekly fulls and daily differentials, transaction log backups on a given RPO. And so it helps to facilitate management, especially if you have multiple SQL servers on Azure virtual machines. If you have many instances, using Azure Backup might provide a cleaner and more centralized management of the backups for your SQL servers. All the backups will go to a blob storage of some fashion. You can also implement third-party solutions. So you can use a third party like a Zerto, which would replicate the Azure virtual machine around for you. There are third-party products that can help replicate your virtual machines around. So let's talk about platform as a service. We just got done talking about infrastructure as a service. Now, platform as a service, one of the best things that I think as a DBA that I like is that it automatically does backups for me. So if I were to stand up a new Azure SQL database, I know immediately that the database is going to be backed up. I don't have to worry about it. I know that the given schedule is the platform is going to do a weekly full, 2 daily differentials, approximately 12 hours apart, and it's going to do a transaction log backup approximately every 5 to 6 or 7 minutes, depending on what your workload is. So that would meet probably 99% of the RPO values and RTO values that my organizations or my clients have. And so having automatic backups makes my life easier as a DBA because then I don't have to worry about it. The service automatically does that for us. By default, with Platform as a Service, you get 7 days of backup retention. And so I know out of the box with no other configuration, we keep the backups for 7 days. I can configure a longer term retention up to 10 years. So I can configure the retention to say, hey, I want to keep those backups for up to 10 years to meet the requirements of my organization. I can also configure annual backups or monthly backups to be retained for up to 10 years. So if I have a organizational requirement to say the first backup of every year, that annual backup we're going to keep for 10 years, I have the flexibility within the portal with the platform as a service tier. Now, and these backups are stored automatically in read accessible geo-redundant blob storage. So when I do these automatic backups, or when the service does the automatic backup, I know that for a fact that it's automatically in geo-redundant storage, which makes me feel as a database administrator even better, because then I know that my backups are automatically stored locally to my region as well as somewhere else. So I can survive any natural disaster that might come along for that given region. The only downside with platform as a service is that because the backups are kept in blob storage, restoring those databases can take a longer amount of time, anywhere up to a number of hours or a few minutes, depending on the size of the database, where it's at, what it's restoring to, all that stuff. So keep in mind with a disaster recovery solution that your restore time might vary depending on the database and where it's at. I would recommend that you test your restores. If you've got Azure SQL databases, go out there and do a test restore to another server and see what happens. Also keep in mind is that you can't restore over top of a new database. With Azure SQL database, you have to either rename the existing database or delete it altogether. The service won't allow you to overwrite that existing database, which as a database administrator, I'm kind of thankful for, so that mistakes can't happen and you don't accidentally overwrite the wrong database. It has to either be renamed or not exist. So I mentioned availability groups with infrastructure as a service. You can do availability groups with a SQL Server on Azure Virtual Machine. It does require a load balancer in Azure. You can use that replica to stretch across multiple regions, as I mentioned. So again, this is where a high availability solution in conjunction with a third node elsewhere, or even a secondary node elsewhere, could be used as a disaster recovery solution. One of the beauties about availability groups within Azure is that you get to take advantage of the Microsoft backbone, which is a pretty big pipe. So if you're using Azure resources, keep in mind that you get to use that backbone to move data back and forth. So your latency might be less. Also keep in mind that when you set up a secondary or third node elsewhere in a different region, you're going to incur charges moving data from one region to another. So while it might be still within the Azure network, you still get charged for moving that data across multiple regions. You can specify synchronous or asynchronous commits with availability group in a SQL Server on an Azure virtual machine. Just keep in mind the physics behind that. Remember that a synchronous commit is going to require the application to initiate the transaction on your primary. It's going to write it to the log, and that log is going to be sent to the secondary. The application is going to wait for the commit to be hardened on the secondary and then come back before it continues. If that distance between the secondary and the primary is across the continental United States, you could introduce latency with your application. So I recommend using the asynchronous. Just know what that terms does in terms of using availability groups. So Geo-Replication, as I mentioned earlier, is for platforms as a service. This is asynchronous in nature, but with Azure SQL database, I can use Geo-Replication to instantiate a replicated copy of the database in another region, or I can use it, a replicated copy within my given region. It's really easy to configure. It does use availability groups technology underneath the hood. It does provide a readable secondary, which is really handy, especially if I want to offload reporting or some other task to that secondary copy. That provides an easy solution for me. And I can use this as a forced failover methodology. The only downside is that either myself as a consumer or my application has to have logic to actually initiate that failover. So if something goes down within the Azure region, we have to manually enforce that failover, but it is possible. Now, the other side of that is failover groups. Failover groups is what I would consider a step up from Geo-Replication. It provides redundancy, and it's defined at the server level. So I have to go into the logical server that is hosting the Azure SQL databases. I configure a failover groups. It does provide read-write endpoints So I can actually use, it actually has a built-in listener basically for it. And that's one of the differences between failover groups and Geo-Replication, is that with Geo-Replication, you'd have to also reconfigure your apps with a new endpoint, as that's not going to change. With failover groups, in the event of a failover, because it has a listener on top of it, the endpoints don't actually change, and all your traffic is routed to the new primary or the new secondary, depending on what you're trying to do. So failover groups allows you to do that. It's limited to certain regions. It does have a 1 hour minimum grace period. And the reason behind that is that the failover groups utilizes availability group technology under the hood, and it's asynchronous in nature, just like Geo-Replication. That grace period, in the event of a failover, an automatic failover from the service, it waits 1 hour. That's the minimum amount of grace period you can specify. It waits that 1 hour to ensure any transactions in flight has time to get to the secondary and get committed before the failover happens. You can force a failover both in Geo-Replication and failover groups. You can force that failover, but know that if you force the failover, any data that might be in flight and haven't fully committed to the secondary is potentially going to be lost. So here's a quick example of differences between Geo-Replication and failover groups. We don't have automatic failover with Geo-Replications, whereas we do with failover groups. We can use multiple databases within a single failover group, which would allow us to fail over multiple databases at a given time. We don't have that within Geo-Replication. With Geo-Replication, in the event of a failover, we have to manually go update our connection strings, whereas failover groups, if we're using the endpoints with the listeners, it'll do that automatically. You can't use Geo-Replication with managed instance, but you can with failover groups. Geo-Replication allows us to have a replica copy within the same region as the primary, whereas failover groups, it forces you to go outside of the region. So again, thinking about different regions, failover groups is my recommended path to making sure that your data is in a different region. With Geo-Replication, I can have multiple replicas. So if I needed multiple readable secondaries, or I want to have multiple readable secondaries spread out across multiple regions, I can facilitate that with Geo-Replication. I don't have that ability with failover groups. And both of them supports read scale, so I can scale them out if I needed to. This is what a Geo-Replication and failover groups kind of looks like. So here we can see that we have a Azure Traffic Manager. We've got some load balancers, and we use Geo-Replication between the two. So failover groups actually utilizes active Geo-Replication under the hood, but then what's on top of it, we have the DNS to facilitate the read-write listeners. So we've talked about quite a bit. We've talked about Azure Site Recovery. We talked about Geo-Replication, various options for both infrastructure as a service in Azure and platform as a service. Let's go ahead and take a look at a demo or two, and we can examine to see how this stuff actually works in Azure. So stay tuned. I'll be right back. Hi friends, welcome back to the demo of this presentation. Remember that we're talking about designing disaster recovery solutions for Azure. So I've got a demo that I want to show you on how easy it is to configure Geo-Replication and failover groups for Azure SQL Database. As we can see that I'm in my portal within Azure, I'm in my tenant, and I've got 3 servers set up in a SQL Bits resource group. So I have an East server, a West server, and a Central server. And on the East server, if we drive into this particular server, we can see that I've actually got a sales database. The sales database is pretty much empty. It's got a single table in it with a single row. Really, it's just to demonstrate how easy it is to move data from one spot to another, and we can verify when the data gets replicated that that data is correct. So if we go into the sales database, we can look on the left-hand side under the navigational blade. There's a Geo-Replication option. Remember that Geo-Replication is configured at the database level, whereas failover groups is configured at the server level. So I'm going to go ahead and click on Geo-Replication. And this is going to bring up a secondary blade. We can see that my primary region is East US because I'm located on the East Coast of the United States. I want my resources to be as close to me as possible to help mitigate some of that physics that I talked about earlier. I want that resource to be as close as possible, so I have my latency as low as possible. We can see that Geo-Replication is not configured for this particular database, but I'm going to go ahead and configure it. Now remember that I've already got a server configured in the West side of the country, so I don't need to configure a new server. It's already out there for me. So I'm actually going to use this SQL DB Server West and the SQL Bits resource group. So that way later when I'm done with the demo, I can just delete the resource group and all my resources will go away. We note that the secondary type is already defaulted to readable and that is already locked in. I can't change that value. I selected my target server already. I could change the pricing tier of that secondary database if I so desired. I could use an elastic pool or change the pricing tier if I wanted to. I'm going to go ahead and make this serverless just to make it cheaper. And when that database gets stood up on the secondary, it will be in that serverless tier and will be automatically paused if I'm not using that database. I'm going to click OK. Now we can see up here we have a deployment in progress. When what that means is that it's using the availability group technology. It's actually doing the auto seeding on the secondary. So right now that database is being stood up and we can see that it is seeding. We can see we have a percentage as to the completeness of this process. But right now that database is being created. The data is being pushed over. Now keep in mind, I've only got a single table with a single row in it. So there is not that much there to move. So if you have a larger database and you want to use Geo-Replication, keep in mind you have to move that data or copy that data from point A to point B. Your duration setting up Geo-Replication is going to vary depending on what you're going on. Also note that you can see that I can specify multiple regions. If I wanted multiple readable secondary copies, I can use Geo-Replication to easily facilitate that. Now note that I'm standing up a readable secondary copy within a few minutes and a couple mouse clicks, and this doesn't take that long to stand up. It doesn't take that long to actually configure and get the process going. So now we can see that the process has finished. My secondary database on the West version of the server is now online and it is readable. So let's go take a look. So here I've got Azure Data Studio. I'm already connected to my East US version of the database. So let's go ahead and look at that database. I'm going to go ahead and click and select the sales database. And we can see down below that I am connected to the East version of the database. Now this is the one table that I have. I have a customer table with one row and just has my own record in there. My first name, John, last name, Morehouse. So this is the data that we would expect to see in that secondary. So let's go take a look. If I change this connection and change this to West, go ahead and get connected. So now I'm connected to the West version, which is all the way across the United States. I am connected to the sales database, so it's already identified that I've got that database there. And if we run this again, we can see that, yep, that table is there and that data is there. That's the data that we expected. So with a couple mouse clicks and a few minutes, now again, this database was pretty small in size, but easy to configure and easy to get a readable secondary copy of your database elsewhere. So that is active Geo-Replication. Let's go take a look and see how easy it is to configure automatic failover groups. So we're back at the main portal screen. We can see our 3 servers. We just got done talking about how easy it is to set up active Geo-Replication. So let's go look at automatic failover groups, how easy it is to set that up. So let's go ahead and go back into our East server. Now remember that Geo-Replication is at the database level and Failover Groups is configured at the server level. So within this blade, we can actually just go to this Failover Groups option. And you can see that we don't have any Failover Groups currently configured for this server. I'm going to go ahead and click Add Group. So the Failover Group has to be globally unique. So you have to be kind of creative in what you name it. But in this case, SQL DB Sales FG, so Sales Failover Group, because it's a sales database. .windows or .database.windows.net is available. I'm going to go ahead and configure my secondary server. I'm going to go ahead and create the one that is in the SQL Bits resource group. I'm going to go ahead and leave the failover policy to be automatic. You can configure this to manual. I'm not sure why you would. You want the service to automatically fail this over in the event that there is a fail or a catastrophe or disaster for your primary location. This is the grace period that I mentioned. As I mentioned before, 1 hour is the minimum that you can do. If you have a highly volatile application, lots and lots of transactions, and you wanted a longer grace period and can withstand the RPO and the RTO for that value, you could bump this up to say 24 hours and wait a day before it fails over. So 1 hour is perfectly fine for the purposes of this demonstration, so we're going to go with that. And I'm going to go ahead and add the sales database. Now keep in mind that I can actually have the sales database in a active Geo-Replication configuration and a Failover Group configuration simultaneously. I'm going to click select. I've got one database within a group. If I had multiple databases that I wanted to fail over all at once, I could easily have selected it within that screen. I'm just going to click create. And we can see that the deployment is in progress. So just like with active Geo-Replication, 5 minutes worth of mouse clicks configuring things. You might have a few more mouse clicks if you don't have the secondary server already configured. In my case, it was already configured for the purposes of this demonstration, but the deployment is in progress, and here in a few minutes we should have a failover group instantiated, and we should be ready to go. And we can see that the deployment finished. I now have my SalesDB Sales FG failover group up. It is active in the West US, so I can actually drive into that failover group. And here we actually get a nice topology map as to where my primary is and where it's being replicated to. The blue dot indicates the primary locations here on the East US region. The green is the secondary copy, which is on the West Coast. And here I can manage this failover group. I can do a failover. I can do a forced failover if I wanted to. Remember that if I force it, I stand to potentially lose data. So again, something you should test thoroughly to understand how much data you're going to lose. And I can add and remove databases within the group if I so wanted. I hope these demonstrations showed you how easy it is to get a disaster recovery solution into place when you're using Azure SQL Database. Let's go ahead and jump back to the slides and we'll wrap up. So back in our slide deck, we'll go ahead and wrap up. Those are 2 quick demonstrations on how easy it is to set up a disaster recovery solution for Azure SQL Database. Here are some final thoughts from me as we wrap up. 1, make sure that you always confirm what your RPO and RTO values. Even when moving to a cloud provider, Azure Cloud, Google, AWS, whatever it might be, you always want to make sure you understand what those RPO and RTO values are so that you can ensure that your disaster recovery solution meets those needs. Those are super critical to know. They could be different than what they might be on premises, so double check. Always keep the physics in mind. I always want to make sure that my resources in a cloud provider is as close to my consumers as possible, except for a disaster recovery solution. I want to make sure that that disaster recovery solution spans a lot of geographical miles, as well as minimize my latency in the event if I have a failover. Make sure you evaluate all the options available for the Azure products. Each one has a unique set of tools that you can use to facilitate a disaster recovery solution. Once you evaluated all the options, make sure you test the process very thoroughly. Have proper documentation, have communication about what that DR failover is going to look like, as well as how it's going to affect your end users and your consumers of your data. If you wanted further reading on some of the topics that we talked about today, here are some URLs that you can go to. I appreciate you being here today and listening to me talk about designing a Azure Data Strategies disaster recovery solution. I'm John Morehouse. I am a consultant with Denny Cherry Associates. My contact information is on the screen. Again, feel free to reach out to me. Thank you very much, and I'll be available for questions and answers. Take care and stay safe.